Okay, here's another case of modeling some quadratic data. This time we're going to have a parabola that's turned upside down. And so if I go here to my data, here's my x and y. I can highlight those and do a Control C to copy. Just come over here and paste, do a Control V, and it just pastes it in there. And there it widened everything to fit the data, and again the red curve is the base and the blue curve is the transformed one. Now looking at this, it looks like I'll probably need this thing to be narrower, but I definitely need it to be negative. So as I look at it, I'm going to go ahead and turn this one off. So we're just looking at the blue one. Now it looks like I want that vertex up here, but I also want the thing to be upside down. So just to make it upside down to start with, I'm going to take this to like negative something, negative 1.4. Now I want this vertex that's at 0, well actually it's not at 0, 0 right now, it's at 1, 1. I want to move it up here somewhere, and it looks like, there's 6, 7, 8. We'll try 6, and this is what, 250, 300, 350. So I'm going to try b equals 6, and so that moved it, oh wait, no, not 6, I need 7. I didn't read that right. There's 7, so I'm here, and then I want to come up here around 350. Well, if I just slide it, it only goes to 10, so I'll just have to type in my 350, and that automatically takes that, takes that over here to a max of 350. I might have to take it up or down from there yet, but there we go. And it's definitely too wide, and so to make it skinnier I need to make a larger number in absolute value, but I want it negative, so it's upside down. And I bring this in, and probably somewhere looking in there, kind of how far I am here, how far I am there, that's probably close to the right width, but I need to move to the right a little more, I think. And so instead of 7, I'm going to try like 7.5. And wow, that worked out very nicely. I'll click up here. The 7.5 went through a few of the points. Now though, these are kind of down here, and so even though it goes through those points, I don't think that's really quite the right answer, because to fit these data the best, because it really should kind of split these. And so maybe it's too tall. I could bring it down a little bit, so let me make it not quite as tall. I'll bring it down to like 345. That didn't bring it down very much. Maybe, what is this? This is 300 down here, so maybe 325. And now, it's looking okay in that, here's some above, here's some below, but there are way more above than below. Maybe I need to make it a little wider again. So instead of 6.3, let's try 6 again. And 6 probably still isn't quite wide enough. So I'm going to try like 5.8. And now notice it goes through that point, touches that one. It's still more inside than out, but and these are kind of sticking up here. Maybe I could move it back up a little bit. So you see it's not You know, I'm just kind of doing trial and error, trying to stick with much as I can with kind of nicer numbers like 330 as opposed to 328.63 or something. Um, and you know, these are hitting those pretty nicely. These are just a little bit above. That one's just a little bit below. And then this one, you know, there's just no way we're going to really make it look great. And so I think I'm pretty happy with this answer here. And so with those data, I think what I have is that A is minus 5.8, B is 7.5, and C is 330. And just to write it all out as a single nicely defined function here, I've got my x minus 7.5 squared, and then what is it, plus 330. And there it is. And so there is my fit to those data. Somebody else might get something a little different. There is a sort of perfectly correct answer, but we're just happy with getting something that looks reasonable and that makes sense to us because we made it. And so there you go. There's another quadratic fit.